Welcome to another podcast. In this episode, we're going to be taking a look at a numeric example for trapezoid rule. And so I have in mind here the integral from 1 to 5 of the natural log of x squared, and below you can see that I've already shown you a graph of it along with a couple of trapezoids that we've created here. And so in total there are n equal to 6 subintervals in this picture. And so what I would like to do is, using trapezoid rule, find the blue area for n equal to 6 subintervals. So what I'm asking for is for us to find T6. Now, in order to find T6, one of the things that you probably want to get used to doing is creating a sort of timeline that mimics the one that we're looking at here. So this is starting at 1 and we're going to end at 5. And if I'm doing n equal to 6 subintervals, then my delta x is b minus a over 6, which is 4/6, which is 2/3. And so my tick marks in here, you see they don't align perfectly with the 2 and the 3 and whatnot. So my tick marks in here, equally spaced, are going to be 1 plus 2/3, which is, in this case, we're going to have 5/3. And if you add in another 2/3, you get 7/3, 9/3, which is 3, 11/3, 13/3, and then 15/3, which is 5. So these are the subintervals here. So you can see that that's at 5/3, this one's at 7/3, this one is at 3 like we expected, this one is the 11/3. This subinterval is at 13/3, and then we've got the one at 5. So creating this little timeline, so you're not going to always have a graph. Creating this little timeline, look at it, is a good way to help you keep things straight, because all this will boil down to now is T6 is delta x over 2, and then remember it's the function value at the left endpoint plus 2 times the function value at the next point, which is 5/3. 2 times the function value at the next point. So all these interior points are going to be multiplied by 2. And then finally the right endpoint, which is at 5, it's only going to be multiplied by 1. And so delta x is 2/3, and so 2/3 divided by 2 is 1/3. And then this is f is the natural log, so my f of x is the natural log of x squared. So f at 1 is going to be the natural log of 1, plus 2 times the natural log of 5/3 squared is 25/9. 2 times the natural log of 49/9. 2 times the natural log of 9. 2 times the natural log of 11 squared is 121/9. 13 squared is 169/9. Times f at 5, which is the natural log of 25 when you square it. So if I calculate all this inside the parentheses, then according to my calculator I get 24.108, which is approximately 8.036. So how good did we do? Well, if you watched the midpoint video, we were looking at e to the x squared, which I couldn't integrate. Here we're looking at natural log x squared, which I can integrate. So I actually want to calculate the integral here and compare it. So we're looking at the integral from 1 to 5 of the natural log of x squared, which we can use a really subtle trick here. Remember, properties of logs say that if you have a power, you can bring the power out. So this is the same thing as this. And if I calculate this, this is 2 times, remember the integral of natural log is x. Natural log, it would be absolute value of x, but both my x's are positive, so I'm just going to say x natural log of x minus x. We're going to evaluate that from 1 to 5. So this is 2 times 5 natural log of 5 minus 5 minus 1 natural log of 1 minus 1. Natural log of 1 is 0. And so if I combine all of this, I have 10 times natural log of 5. And then if you look at the constants, 2 times 5 is negative 10. Negative 1 would be plus 1 times 2. So negative 10 plus 2 is, in this case, negative 8. And if you evaluate that, you get that that is approximately 8.094. And so if you compare these two, they're pretty close. And so in the next video, what I'm going to do is show that the actual value of the integral, 8.094, falls inside the interval that we should get when we try to do an error bound for trapezoid rule. So I hope that you'll watch that video. Thank you for watching.